Hey, this is Shane from Performance EV. Today we're going to take a look at how I got all that data from the Nissan Leaf BMS. Hey folks, welcome to the channel. Thank you so much for joining us. For those of you new to this channel, this is my project to put a Nissan Leaf motor into a Porsche 911. Now, in the last video, last couple of videos, I've been working on the battery pack, and in the last video, I managed to get a bit of data from the pack itself to see how good it was, see what state it was in. It's actually in really good nick. But I got a lot of questions on the video about different aspects of how I got that data, or what information it was, and I just wanted to kind of share with you guys everything I used, how I went about getting the data, in case anyone's trying this sort of project at home themselves. So I guess we'll call this how to read from a Nissan Leaf BMS 101 lesson. Alright, so first things first, we want to talk about the BMS itself. So the BMS basically takes obviously the signals from all the individual cells and uses that to tell you things like the voltage and that sort of thing. It also takes details from a couple of temperature sensors that it has dotted around the pack, and then it just hooks into basically a lot of the other components that are kind of going on in the battery, and we'll look at those components in a minute. So the BMS itself, I'm not going to take this apart because it's working and I don't want to break it. But this is basically the second generation of BMSs. The first generation, I think, was mainly just on the 24 kilowatt hour packs, and then from the 30 kilowatt hour packs onwards, they're using this second generation one. Number of inputs is pretty much the same across all of them. It's reading effectively 96 cells, even though in this particular configuration it's 24 modules. In previous configurations it was 48 modules. But either way, getting down to the cells, there's 96 of them, and that's what it's reading. And the setup is really simple. It's basically all of this lower section here, because it sits kind of like that in the car. This is just your 96 inputs for all of the cells, and that's just taking the data and then presenting it to you in a way that the system needs. Then along the sides you've got temperature sensors, so there are 3 of those on this particular pack, whereas I think there were 4 in the earlier packs, but that's fine. This one takes in the 3 and that's all good. And then here is where you've got the other connections. So I kind of touched on them briefly on the previous video, but I'll go into them in a bit more detail in a minute. So this is where you provide power to it, and this is where you get data from it. This is data going into the module, and all of these are data going into the module. Now, where people have hit trouble is using the wrong module. So using one from an older pack on a newer pack, or vice versa. It's not impossible, but unfortunately Nissan switched a few of the pins around, and that can lead to trouble, because basically the way the connections go into the BMS, they're taking a voltage reading, which, if it's wired correctly, is just max 3.75 volts or something like that, because it's just going from the positive and negative on 2 cells. But if you get it wired up wrong, or if they've changed a pin or 2, then instead of reading the value from the same cell, or even 2 cells that are close together, you could actually be taking a positive from one cell and then a negative from a cell that's 3 or 4 modules away, and all of a sudden, because you've wired up the battery, the voltage between those 2 points is much higher, and that can fry the kind of more delicate electronics they've got in here, which is used to help you read the signal. So that's the reason why I was being really pedantic about double checking that I was getting the wires right and that they were being wired up correctly, because I'd read some horror stories from people about this. So yeah, worth taking the time up front to not fry this and then have to go and find another one. Plenty of people have actually done some really good work on these in terms of figuring out what the pins are. So if you do end up with an older one for a newer battery pack, or the other way around, there is information out there that people have gathered, and they'll tell you how to repin the connectors to figure it out. And people have also, they've done some great stuff. They've also taken the connectors and figured out, right, where can you get them from. So these are just basically standard TE connectors, so you can actually buy them off the shelf. And if you need to run a section of the battery pack in a strange place, or split it into two and have it either end of the car, like I may end up having to do, rather than having to cut and splice the loom that's already there, you can just create an additional loom with the right connectors. They'll just plug into this end and plug into the other end, and then you've got a solid system that's not likely to fail as it would if you've gone and had to splice or solder wires together. So I'll put some links to some of those chats on forums and stuff in the description below, because I think it's really useful information to have. So that's the BMS. Now, having the BMS wired into the battery does me no good. I provided power to that, which was cool. It meant that I could hear little ticking noises coming from inside it because there was things happening in the electronics. But again, that's not doing me any good. I had to get data out of it. So there are two ways that I managed to get data out. I guess I'll go with the simplest but toughest at the same time. So what I've got here is an Arduino. So this is an Arduino Mega. So this is their kind of really big one with lots of inputs and outputs, both digital and analog, with the 256 chip on it. So it's got a decent amount of processing power and memory for the type of basic kind of sketches that you write for an Arduino. I'm planning to use this one because I actually want to have a little ECU that can take information from the Leaf and probably from the Porsche, and do various things with it. So I want to take things like the information about the battery, and see if can I turn that into a signal that can be interpreted by the fuel gauge on the Porsche, so I can see at a glance how much I've got. Likewise, there's no RPM information going to the Porsche at the moment, but I will have that sort of information. I'll have the number of revolutions coming from the inverter, so it'll be telling me what the motor's doing, and that will be another output that I'd want going to the rev counter on the Porsche, and that will then hopefully let me see what's going on there, again at a glance, without having to go through too many screens or menus or anything like that. Again, temperatures, want to see if anything's overheating, like hopefully be able to tell myself that sort of stuff. So there's going to be a lot of work to do to actually write all that, and I'll probably end up using bits and pieces of code that people have already put together, but basically that's the plan. Now that's fine. I can use the various types of outputs on this to send a certain type of signal that hopefully the dash will understand, but in order to get the information into this, there's only one type of signal that I'm interested in, and that's a CANBUS signal. So CANBUS is a kind of network protocol. It's not just for cars, but it's used a lot in the automotive industry. Most cars since the early to mid 2000s even have pretty much run entirely on CAN, and you can see it in cars even earlier than that, just depending on the manufacturer and the country they are from. It's basically a system that allows the car to act like a dispersed computer network. So you've got tons of little computers all over the car, and they're just receiving signals on this one big network loop, telling them what to do. So instead of having to have, tons of wires going from one central point out to all different points on the car to control all the different little things, you can just have the signal wire going almost as a loop around the car, and each little module or each little computer on that loop is really just keeping an eye out for the signals it's interested in, or sending signals to somewhere else, and it's always using a kind of a naming convention to say, right, this is a signal for the dashboard, this is a signal to turn on the headlights, and yeah, they know how to do that. Because it's a well-defined protocol, there are plenty of ways that you can actually read it. So from the Arduino perspective, there's quite a number of CANBUS shields that have been created. The one I'm using is the Seed Studio. So this is their version 2 of their CANBUS shield. So it's got basically all sorts of input and output throughs that allow it to just sit on top of the Arduino board, whether in this case whether it's a Mega or a Duo. It can just slide on top and you can still use those inputs and outputs, but it has the necessary hardware on it to be able to interpret and read the messages that are flying about the CAN network. And then it has space for an SD card, so you can either store the data on an SD card or you can output it somewhere. So when I'm got the Arduino hooked up to the computer, I can look at the information there, but you've also got different output options to kind of show what's coming, what it's reading across the CANBUS. This is where it gets complicated though, because every single manufacturer has their own specification for what the messages actually are, and that's a bit of a pain because they don't really want to share it. It's their own commercial information. So that whole thing with the different manufacturers having their own kind of proprietary messaging structure within the CANBUS protocol is part of the reason that when I hooked this up to the BMS and kind of looked at it, all I could really see was that there was data coming across. I couldn't see any more information around what that data meant, just that it was flowing across. That's obviously not useful to me in the long run, so I'm going to have to get some software onto this that will interpret each of those individual messages that's coming across and figure out what it's trying to say, and then go and do something else based on that. And probably also it'll need to send some data to the BMS as well, because this is designed to be part of a network, and if it's not receiving any other signals on the network, then it kind of just goes back to sleep. It doesn't want to do anything else. So in order to be able to integrate it properly into the Porsche, I'll need to have some software on this that will send messages to the BMS, get the messages that come back and interpret them, and then hopefully do all those things that I said I want it to do once it's actually plugged into the dash on the Porsche. But that's all for the future. I wanted this information now. I was really impatient. I wanted to see how that battery was going, and I think with a lot of things in this car I'm a little bit impatient. So what I did was I needed something that could interpret those CAN messages already, and that would also be sending those signals to keep on prompting the BMS to do something. And that's where LeafSpy came in. So LeafSpy is an app that was written by some members of the kind of Leaf community because they wanted to know what was going on inside their cars. They wanted to know more than was just being displayed on their kind of dash of their Leaf, to really understand how the car was working, understand what stage it was in, see if the battery was still okay, because the cars are getting a bit older. Some of the early batteries are starting to show their age. So they created an app that basically used all the information that had been collected around the CAN protocol that goes through the Leaf and interpreted it and then started presenting it in graphs and everything. But of course they designed this to be used with the car as a whole. So what they did was integrate it with an OBD2 scanner. So basically, you get an OBD2 scanner like this, plug it into your Leaf, and run LeafSpy, and then it can interpret all the information that's being sent out the OBD2 port to allow you to get the info on the car. So I mean, OBD2 is a protocol that it's in place on most cars, certainly most modern cars, and it allows for diagnostics and control of the car whenever it goes in for things like service and that sort of thing. So if your car is showing errors on the dashboard, it might just have a very vague description. Someone can plug a specialist scanner into the OBD2 port on the car, and they can see what that actual error code means, and if the problem's been fixed, they can actually do something like reset it, or reset the engine time and this sort of thing. So this is it's a very well known protocol, and there are plenty of expensive scanners out there that are either company specific, so they're designed to just work on a Porsche, or just work on a Nissan, or just work on a BMW, or you can get ones that are a bit more generic. They might not be as fully featured as those standard one manufacturer ones, but they'll do a lot of the things you want. So I have one that I've used on the Porsche a few times, and I use it for things like resetting the airbag sensors when I've been fiddling around with the dash and the seats and all that sort of thing, or checking to see what state the car was in when I first got it. Not great shape, and all that sort of thing. But they're kind of quite standalone. They're clunky. They're designed to be used in a kind of workshop environment with grubby hands, so they're usually waterproof and drop proof and all this sort of thing. They're not really designed to send data across to other things. But you can get these wireless versions, which don't do any interpreting themselves. All they'll do is take the data that comes into them, and then send it to your phone, your computer, whatever, and then you need software on there to be able to interpret what it is. So LeafSpy is the software I've got on my phone for interpreting what's in the what's happening in the Leaf battery pack. But I had to figure out what pin to use on this, because the OBD2 actually covers a range of different protocols. CAN is one of them, but there are 2 or 3 others. And the way it can do that is it's got different pins associated to different to the different protocols, and then depending on which ones it's receiving the signal on, that's the one that it then does its magic on and sends through to the phone. But once I'd figured that out, it was really just a question of being able to plug it in, plug in the CAN wires from the Leaf BMS into here and a bit of power, and then I was able to get LeafSpy to speak to this and start interpreting the messages. And the guys that did the LeafSpy thing, I have to say thanks to them, because they, as well as working for the Leaf as a whole car, they also put some settings in there that you can put on it so that it'll work with just the battery out on its own. So whether you're using it in another car like I'm doing, you're trying to build a power wall or something like that, you can use the app to do it. And there's a free version. I paid for a version so that I can start logging some data. So the plan is basically short term, I can use this to keep an eye on the battery while I'm still working on trying to get more information interpreted through the CANBUS thing. And I'll be able to hook this up to the or I'll be able to get the head unit that I have in the car speaking to this through Wi-Fi, and it'll then be able to display battery data and stuff as I'm driving the car and testing things and that sort of stuff. So that's going to be pretty cool. So those are basically the main components that came into trying to read the Leaf BMS. Now let's go over and take a look at the battery itself and see. I'll show you just the rest of the wiring that I had to do to make this work. Alright, so the first thing I wanted to talk about was just the signals that are actually coming into the the Leaf. So you've obviously got the connectors here that are going ultimately through this additional loom heading back down to the BMS. And what they're taking is one wire from a main terminal that's basically crossing between two modules, and then one wire each from the middle. Now, the way these individual modules are hooked up, there's actually multiple cells in there, both in parallel and in series, to give you a total module. I think it's about 7.5 volts, and this pin here is kind of bridging the two of them. So if you read between this central one here and this top one, you'll get the reading for half the cells in here, and then if you're reading from here and this one, you're getting the other half. And the way the Leaf BMS does it is you've got one, as I said, one signal wire coming from each of the bridged ones, and then based on the software and hardware within that that BMS unit or LBC unit, it's checking the voltage between here and here, and then also the voltage between here and here, and the voltage between here and here and here and here. So it doesn't have two wires for. It's actually cut down the number of wires that it's needing to get the voltage, but that means that this particular pin here is positive or negative depending on which set of cells it's reading. So it's quite smart that way, actually, and yeah, means that they get away with, well, there's still a lot of wiring, but they're getting away with less of it. But that means there's plenty of data coming out. But that's, because of all these wires is why you've got kind of 4 sets of inputs going in for just the wire, just the voltage information, and then only a single output for everything else. So this one is an interesting one. So obviously we're pulling the CAN message comes out of here, and we've got our voltages going into it as well. So we're sending positive and negative, along with like a switched positive into the BMS through this little connector, and that's enough to kind of switch it on and send some signals. But there's a lot of other wires there as well, and it was only as I kind of really started to try to figure out what each wire was, that I ended up basically reconnecting all the internals from the whole battery pack, from the big battery pack that I dismantled, because the BMS itself, it needs more. If it's going to really protect the pack, it needs to know a lot more information. So it's got things like the this kind of big interlink thing here that basically stops the pack from sending voltage outside of itself once you remove the thing that I can never get my hands on. But basically that's got a signal, and if that's bridged, i.e. this is in place, then the battery is able to do things. If this is removed, it's not going to do anything. So that's a signal that has to go in through that connector. Then you've also got signals coming from kind of the main contactors and the kind of voltage and current sensors that are in place to let the battery know when there's power actually going through things. So in the end, the connections that I needed for both the BMS and the OBD2 scanner were very similar. So there was a range of negatives, so earth connections, that I had to put in place. So there were 3 going into the BMS, there were 2 going into the OBD2 scanner. There was some positive. So in this case there were 2, basically just a kind of standard live and then a switched live going into the BMS, and just a standard live going into the OBD2 scanner. And after that, it was just a question of connecting up the CAN wires correctly. So CAN high to CAN high, CAN low to CAN low, between the the BMS and the OBD2 scanner, and that then allowed me to get the information I wanted from the Leaf. So ultimately what I'll want to do is have a more permanent set of wires going in to provide the power to the BMS at the appropriate time, and just as importantly to get the CAN information out. And then I'd like to have actually a proper OBD2 port that I can put the scanner into, rather than having the rather than plugging wires in like this, which is never a permanent situation. What I may end up even doing is you can get a serial to OBD2 cable, so that I'd actually wouldn't run CAN directly into the OBD2 port. I'd be running it into the CANBUS shield here. Whether I've got that interpreting data or not, it might just be reading it initially, and then I'll use a cable to provide this with the power it needs and the CAN information, and then get the information from LeafSpy via that. So the plan that I have initially is probably... So there we have it. That's kind of how I went about checking out the Leaf BMS in a bit more detail. I'm going to put plenty of stuff in the description below, just about the different products I used and different applications, and then as and when I get things working with software, I'll make sure to put that up on GitHub and include it in the description, whatever video that is. Because I'm actually really excited to see what can be done to kind of integrate the two different systems together. So yeah, I hope you found this video useful, interesting, or whatever. And that, yeah, if you've kind of liked this sort of thing and not already subscribed, please consider subscribing. And if you want to leave a like or a comment, it's always appreciated. As I say, I do try to respond to as many comments as possible. It's one of the reasons why I did this particular video, was just based on the number of comments I got. But yeah, until next time, thanks for joining us, and we'll see you soon.